All right, thanks. Thanks for coming on this Memorial Day weekend. Um, this was the bones of this presentation were a 15-minute talk that I gave at our Bhaktivedanta Institute for Higher Studies Consciousness and Science Conference in 2019. This is actually the first thing I did for the Bhaktivedanta Institute back then. It was a while ago now, more than 4 years ago. And at the time, I was a research scientist in the Department of Earth and Atmospheric Sciences at the University of Alberta. So I tried to strip all of, and so the University of Alberta funded the plane ticket to come here because I had a travel budget and it was an academic conference. But I had to put their corporate logo, their corporate design PowerPoint slide, and I tried to strip it out of this presentation, but apparently I failed on the first slide. But there was a whole banner on the bottom that had anyway. So I've seen it anyway. So the question here is, so there's a question: does modern science falsify Vedic claims about the age of the Earth? And the answer is no. So we can all go home now. No,
but there's an asterisk.
There is an asterisk, and I even noted that in the slide that there's an asterisk. And we will come back to that later. Before we come back to that, or we'll come back to that after we talk a little bit about what is time. So what are we talking about when we talk about time? To begin with, we know that in the Bhagavat tradition, in the Bhagavad Vedanta tradition, that most of the audience is oriented towards or within, time is an essential feature of the material world. It's one of the 5 main topics of the Bhagavad Gita. And time is like the framework under which all of the other topics of the Bhagavad Gita exist or operate within. But it's also kind of pinned that, but it's also hard to talk about time, like what is it exactly? So I have a little bit of a dictionary definition here, that time is the continued sequence of existence and events that occurs in an apparently irreversible succession from past through present and into the future. That's from Wikipedia. I've heard other definitions which describe time as the interval between 2 discrete events. And so there's many different definitions of time. But when we talk about time, we're usually talking about some kind of a progression. And we see things that happen that happened before now, things that will happen ahead of now, and what is happening now. So the past, present, and the future. Time is typically viewed either cyclically or linearly, and even within one worldview or one cultural or philosophical orientation towards the world, often these things can exist in tandem. So we tend to see time linearly. There was a start date and there's an end date, and it's just marching inexorably into the future. But we also see time cyclically in terms of seasons, days, and events that happen in repeatable areas, eclipses and whatnot. So sometimes we see that time operates in cycles. Other times we see that time operates linearly. The ancient Greeks, who in our Western culture were the first people, not the first, I shouldn't say that. The ancient Greeks, who talked a lot about time, separated time into chronos, which was the quantifiable aspect of time. That's the ability to measure the distance in time between those 2 discrete events taking place. And they also talked about kairos, which is when is it the appropriate time to do something. And so this was more of a qualitative type, like it's time to harvest the wheat. And there's a little bit of both in there. They were able to measure the cycles of the seasons, have a good sense of when it was time to harvest the wheat. But then there might also be some local atmospheric determinants for that. Like, well, I know from living on our farm in Germany, Semhachelen, where Nishringadev lives, that you can't harvest the wheat if it's been raining. You've got to wait for it to dry out for a few days. And so there's the idea of the quantifiable aspects of time versus the qualitative aspects of time. And then, of course, this is not an exhaustive list, but then within the world of physics, the science of physics, the physical sciences, there's the notion of absolute time, which was like the Newtonian time, which is that each point in time is its own discrete thing unto itself, and it has an objective reality and an objective 3-dimensional space and more relative time, which was the modern, more Einsteinian concept of time, which is that time and our perception of time fluctuates based on the situation of the observer. And especially at the speed at which the observer is moving relative to the event that they are observing. So there's, of course, Einstein's special theory of relativity. And so time is a huge topic. We're not going to be able to address all of it. I will address a little bit of it in the history of the Western world, as well as how it's described in the Bhagavatam. And then we're going to use this to explore the idea of whether or not the scientific method disproves Vedic conceptions about the age of the earth. And that is more of an exercise, again, in epistemology, rather than trying to derive a correct answer. So let's get into it. How do we measure time? Well, time has been measured in many different ways. Like I mentioned, there's quantitative and qualitative ways to measure time. There are also cyclical and linear ways to measure time. So what we have up here on the top are the ways that people first began to measure time in terms of, I'm just going to show some pretty pictures rather than go through that whole list, because nobody wants to watch me read a PowerPoint. But going way back when, this is, of course, Stonehenge, which dates back to at least 3,000 years before Christ. People used monolithic structures such as this in order to measure the cycles of days, seasons, years, and so on. So up here in the upper left, this is an archaeologist or an anthropologist's reconstruction of how this worked. But all of these stones were oriented so the people who lived in this part of the world could precisely tell the position of the solstices and the equinoxes. And in this way, they were measuring time cyclically. And they would use this for their rituals, for their harvests, for their fertility rites, to regulate their society. So they used this semi-qualitative determination to regulate their society. Going back in terms of the more quantitative measurements of time, this is a water clock. This is a water clock that was found in the tomb of Pharaoh Amenhotep I, dating back to, I could get this wrong, so don't hold me to it, but I think about 1500 BC. And this is considered, this is an artifact in a museum somewhere. I don't know what museum. But this is considered to be the most ancient water clock, the most accurate water clock of the ancient world. And this would typically have a opening on the top like this, and it would have an opening on the bottom, as we you can't see the opening on the bottom here, but they would pour water into it at a known rate, and then the water could exit the hole at the bottom of a known rate, and then based on the difference between those two things, the water pot would fill up at a predictable rate of time. And so they would use this to measure time in a semi-quantitative, actually in this case a fairly accurate quantitative manner. And the advance of this over the stone circles, which were found not only in Stonehenge, of course, but all over the world in different forms or another, is that this could be used to measure time at night. And so it was fairly common ancient technology to be able to measure semi-quantitatively the length of the day based on the passage of the sun in the sky and knowledge of the precession of the equinoxes, which is very ancient knowledge in human civilization. But to be able to do that at night when you cannot accurately track the sun was more challenging. And so the water pot was a major advance on this. And this was also technology that was found throughout the ancient world, but the Egyptians supposedly mastered it. This is a sundial. Of course, sundial works. The central feature of the sundial is the gnomon. We talked about mnemonic mapping in a previous session. And basically, these were calibrated to the latitude that you were at. And based on the time of the day, the sun would cast a shadow on the gnomon, or the gnomon would cast a shadow at the time of the day that it was. And it was broken into 12 hours, and we go around the 12 hours of the day, roughly. And if anybody's wondering why there are 12 hours and 60 minutes in a second, or 60 seconds in a minute, 60 minutes in an hour, and this is all around the number 12, is that because the Babylonians who developed this system used a base 60 mathematical system for reasons we're not going to get into right now. So that's the sundial. Again, now we're breaking the day down into equal repeated cyclical increments over time. This here is an hourglass. This was used, for example, Ferdinand Magellan had 18 of these hourglasses on his boat, by which he could keep track of time sailing around the world. So again, these were able to keep time during the day and the night, and now these were also able to keep time independent of your latitude on the Earth. And also, so an issue, let me go back a little bit. An issue with the water pot is that in order for this to work 24 hours a day, you needed somebody to watch it all the time because it eventually would fill up and spill over. And so, you know, the pharaohs, the priests, they had, this was like a holy religious duty, was to keep the time. It's like the court timekeeper was an important thing. These things, they just needed to be flipped over. And they would start working again. And so they had a guy on ships that would just be aware to flip it over. And they had 18 of them on Magellan's boat. And so this was able to also map time. And then as opposed to a sundial, which was engineered for a specific latitude, these you could sail north and south on the Earth and it wouldn't change the amount of time that it would take for the sundial to work. So this is a little bit more modern technology. These started to become in fashion around the 12th century. And that did enable seafaring to expand. Of course, then in the 16th century, Magellan, this is a replica of one of the hourglasses, sandglasses Magellan had, which is why I keep talking about Magellan. But he was able to use these to circumnavigate the globe and to, at that time, accurately map the globe. And then, of course, the British Empire, they developed chronographs. This is a modern chronograph called a clock. And the chronograph enabled the British to far exceed all other nations' seafaring capabilities in the 17th and 18th and 19th centuries, because they were able to very accurately keep time, not only based on regardless of what latitude they were at, but also where longitudinally they were on Earth. So it's much easier to tell what line of latitude you're at on the Earth based on the position of the sun than it is to tell what line of longitude you're at, because you could be traveling anywhere and going perpendicular to a line of longitude. And so to be able to tell the time based on a standard, which was in Greenwich, England, that's why we have Greenwich Mean Time now. The chronographs that the British all had were standardized to the time kept by a clock in Greenwich English. And so they were able to very accurately keep time all around the globe, which allowed the British Empire to expand around the globe. Anyway, these work again on the Babylonian base 60 system with gears, 60 seconds in a minute, 60 minutes in an hour, 12 times 2 hours in a day. And this is going around and around and around. And these gears are precisely engineered in order to maintain those divisions. And there's a number of ways in which these gears can be propelled. Sometimes there are weights hanging on the clock that are run by gravity. And when the weights hit the bottom, the clock needs to be cranked back up, reset, and it goes again. And so there's a little bit of a discrepancy. Every time you reset it, you're introducing human error into it. They can be run by the swinging of a pendulum, like a grandfather clock. And again, from time to time, someone needs to come and hit the pendulum again to keep it going. They can be run by a spring, like a standard mechanical watch, which needs to be wound up. And the spring itself needs to be very highly engineered to have the correct spring constant to move the gears at the correct rate. Excuse me while I take a sip of bubbly drink. Thank you. Or now we have these things that were done electrically with a battery. They can just drive around. And of course, now we have smartwatches, which are run based off of the principle of an atomic clock, which is what this is. And I know that that doesn't look like a clock, and nobody would really know how to read that. It's basically just putting a number on a computer screen. But this is how we keep track of what a second is in the modern world. And we've all agreed, based on the work of the Babylonians, that a second is 1/60th of a minute, which is 1/60th of an hour, which is 1/24th of a day. And we know what a day is because that's the length of time it takes the Earth to rotate once around on its orbit. Not on its orbit, on its axis, sorry. Yeah. And so what is a second? So how do we define what a second is then? And we use atomic clocks. And atomic clocks work on the basis of if you have an atom and you hit it with an electromagnetic vibration, light, in this case, a microwave, which is a form of light that you can't see, it will have a resonant frequency with that radiation. And that is an extremely stable and long-lasting radiation. So if I zap, and in this case, we use the cesium-133 isotope we zap it with a microwave, and the electrons in orbit around the nucleus of that atom will jump up to a higher energy state and then decay back down into what's called their ground state. And they will do this approximately 9.9 million times in 1 second. And that is the definition of a second. It has to do with the rate of the vibration of those, of the excitement and rest energy of the electrons in orbit around a cesium nucleus, cesium-132. So that's an atomic clock. And so these things are accurate over millions of years. They might lose 1 second of timekeeping accuracy over the time span of all of what is known of human existence on Earth. And so that's how all of our smartwatches, all of our GPS satellites, they're all coordinated with these atomic clocks. And there's a laboratory, I think, in Switzerland that keeps the standard atomic clock. And that's how we define what a second is. I know that sounds kind of convoluted. But it is interesting because in the Srimad Bhagavatam, the calculation of time is also derived from an atom. And the way that the Bhagavatam describes an atom is very much the same as what we describe atoms as in modern science, which is that they are the fundamental building blocks of all other forms of matter that we see. Now, there are, of course, some very significant differences between what we describe as atoms and what the Bhagavatam describes the atom as, but the principle is the same, is that these are the fundamental building blocks of nature. And rather than just put all the words of this on the screen, I am going to read this for you. This is from the section of the Bhagavatam where Vidura is discussing metaphysical topics with Maitreya Rishi. So Vidura was the brother of Pandu and Dhritarashtra, the third child that was born of Vyasadeva after Vyasadeva kind of slept with some courtesans of the Yadava dynasty. The third one, so Vyasadeva was kind of this, I'm going to say poetically, sort of not well-groomed, sage-like creature who just appeared out of the forest to do his dharmic duty of creating some children. And the people who were to bear those children didn't find Vyasadeva all that appealing. So they went through various, what do I want to say, schemes to try to avoid the unpalatable duty before them. And one of them replaced themselves with a servant girl in the court. And Vidura was born of the servant girl, who was sort of a lower caste. So Vidura, of the 3 sons, was considered to be sort of a bit of the black sheep, or a bit of not as highly regarded, and therefore could not ascend the throne. But he did hang out in the court a lot, and he did often, he was a minister and a guide. And he left one day after being insulted. Somebody insulted his mom. And so he's like, I am out of here. And he kind of yelled at everybody and stormed off into the wilderness, where he met Vidura, and they had transcendental talks. And I'm just going to read a little bit of this to you. The material manifestation's ultimate particle, which is indivisible and not formed into a body, is called the atom. It exists always as an invisible identity, even after the dissolution of all forms. The material body is but a combination of such atoms, but it is misunderstood by the common man. Atoms are the ultimate state of manifest universe. When they stay in their own forms without forming different bodies, they are called the unlimited oneness. There are certainly different bodies in physical forms, but the atoms themselves form the complete manifestation. Here's the relevant part now. Not that that was irrelevant, but one can estimate time by measuring the movements of the atomic combination of bodies. Time is the potency of the almighty personality of Godhead, Hari, who controls all physical movements, although he is not visible in the physical world. Atomic time is measured according to its covering a particular atomic space. I just want to make a side note here. This is very much relevant to what we were talking about last week with the Big Bang and the Planck time. Is that the Planck time is the time it took for the universe to expand to a large enough dimension that gravity could be separated out from the other primary forces in a mathematical sense. And so there is a space element related to time, as we know from Einstein and other scientists. So atomic time is measured according to its cover a particular atomic space. That time which covers the unmanifest aggregate of atoms is called great time. The division of gross time is calculated as follows. 2 atoms make a double atom, and 3 atoms make a hexatom. A hexatom is visible in the sunshine, which enters through the holes of a window screen. One can clearly see the hexatom goes up to the sky. So this, I think, is apparently describing something bigger than what we would know of as an atom, because a hexatom here, according to this math, would be a carbon atom. And certainly we cannot see a carbon atom. So 1 atom and 2 atoms, to get 1 atom and 1 atom together makes 2 atoms, which would be helium. And then 3 heliums would be 6 protons, which would be carbon. But I don't think that's what this is describing at this point. Anyway, the time duration needed for the integration of 3 of these hexatoms is, of 3 of these hexatoms is called a truti, and 100 trutis make up a vedha. 3 vedhas make up 1 lava. The duration of time of 3 lavas is equal to 1 nimesha, and the combination of 3 nimeshas makes 1 kshana. 5 kshanaas combined together make 1 kashta, and 15 kashtas make 1 lagu. This is coming to a point here. 15 lagus make a nadika, which is also called a danda. 2 dandas make up a muhurta, and 6 or 7 dandas make 1/4 of a day or night, according to human calculation. So again, they're coming back to this basic unit of measuring time, a day, and then they're breaking the day down into various segments. So muhurta, we know muhurta is something that we use to regulate our religious activities. So that's a necessary function in human society. Now,
do you think you could put that up on your share?
Put that up on the screen.
You might have to like unshare and reshare if it's in a different window.
Do that. Thank you. Here we go. Here we're on verse 9 now. So now that it becomes interesting, it says that the measuring pot for 1 nadika or a danda, so remember 2 dandas make a muhurta. Danda is a half of a muhurta. The measuring pot for 1 nadika or danda can be prepared with a 6 hala weight pot of copper, a 14-ounce pot of copper, in which a hole is bored with a gold probe weighing 4 masa and measuring 4 fingers long. When the pot is placed on water, the time before the water overflows in the pot is called 1 danda. So they just described a water clock. And they described a water clock made out of copper, in which a hole is bored in the bottom. And they give you the weight of the copper and the length of the copper. Not the copper, the gold. And because the density of gold was very well known to the ancient Hindus, because the way to know if you have a mass of gold that you're not being cheated is to measure its density. And so if you know the density and the length and the weight of this, you can determine what the diameter of that borehole would be. So they bored a hole in the bottom of this 14-ounce copper pot. So 14 ounces is I would like to conjecture that the pot holds 14 fluid ounces, not that it weighs 14 ounces, because that would not uniquely determine enough of the pot. But that is my speculation based on readings. So anyway, there's a hole in the bottom of this thing, and when you put it on water, it'll slowly sink as it fills up with water. And the length of time that it takes for it to sink to the bottom is 1 danda. And a danda is a half of a muhurta. So it's calculated that there are 4 praharas, which are called yamas, in the day and 4 in the night of the human being. Similarly, 15 days and nights are a fortnight, and there are 2 fortnights, white and black, in a month. So now they're expanding again the quantitative derivations of these qualitative cycles that they had observed in the sky. The aggregate of 2 fortnights is a month, and that period is 1 complete day and night for the Pitta planet. So that's 1 month for us is a day and a night for people on higher planetary systems. 2 of such months comprise a season, and 6 months comprise 1 complete movement of the south to the north. So that is from the summer solstice to the winter solstice. 2 solar movements make 1 day and night of the demigods. So 1 day and night of the demigods is a year of humans. And so we see that time is relative based on the viewpoint of the observer. Human being has a duration of life of 100 years. I think, was there anything else? No. So there you go. So that's, oh, yes. And then here at the end, I'll come back to this again. So here it then talks about, based on the calculation of the years of the demigods, how long the yugas are. And so the Vedas also talk about not only seasonality within the rotate on the earth on its path in the orbit around the sun, but it also talks about seasonality of consciousness of living entities within the universe in the 4 yugas. And I want to come back to that in a moment. That's the bit from the Bhagavatam. And now we're going to answer the question. What was the question? Anybody remember what the question was?
Does modern,
does modern time
Right. Yeah, right.
Science disprove Vedic claims about the age of the earth.
We've got note takers. Okay, so before we do that, I want to just revisit our overall theme of epistemology here. And so this is, we have empiric knowledge, which is what can be directly measured with quantifiable units that are not dependent on anything having to do with the situation of the observer. And then we have consciousness, which is really the opposite of that. You know, consciousness is actually a completely subjective thing. And I have, even though we have language that we share in common with which we can describe our conscious experience, I really have no way of knowing if what we are agreeing on as the color green is perceived in the same way as green by all of us. Or, you know, he hears me speaking English in this way, she hears me speaking English in some total other way. We really have no way of knowing that. And between these two sort of poles, there is a shades of gray. There's perception, so we can all agree that we're perceiving a table here, maybe. And we have some fundamental observations that we can agree upon about the table. The table is solid matter. I can put things up. And so it's not that it's unobservable, but these things are all generally personal, subjective, and qualitative. My experience of this table being hard is not the same as your experience of the table being hard, although we can both agree that the table is hard. The scientific method is quantifiable in consensus. So we don't say the table is hard. We develop a scale that we can agree upon that will show what the hardness of the table is, what can scratch it. And with wood, there's a scale. With rocks, there's a scale. With metals, there's a scale of hardness. So we can agree, okay, it might feel hard to me in this way, it might feel hard to you in that way, but on the scale that we've designed using our scientific method, this is how hard it is. And really the bridging or the unifying force between these two things is mathematics. Mathematics, the laws of mathematics that we've discovered are immutable, or that is at least the theory with which we operate on. I did have somebody tell me in an angry email from my last talk last week that the Bhagavad Gita disproves Euclid, which I don't think that's the case. But anyway, people come up with some crazy ideas. You can continue sending me your angry emails. So now we're talking about the age of the earth. And so the age of the earth, this is something that, you know, we can go out into nature and we can see all kinds of clues about what the age of the earth is. And I used the example previously in the previous talk about the Grand Canyon. You know, the young earth creationists will go to the Grand Canyon and they will point out that this is evidence of a great flood that took place on this earth 6,000 years ago. So that's their observation and their perception. The scientists will go there and they will point out that there is at least 1.8 billion years of geologic history exposed in these rocks. And that is their perception and their observation. So how do we know who's right? And then the Vedas, of course, have a totally different take on it, which is that it's way older than even the material scientists will say. So the question again is, does modern science, so modern science, let me just say clearly, modern science definitely disproves the age of the earth, according to the young earth creationists, along many different lines. So the young earth creationists are making a claim that the earth is this old, and there is observable evidence coming from the scientific knowledge that can, scientific method that can show us empirically that that is wrong. And so that's a falsifiable hypothesis that has been falsified. The Vedic claim we'll get to in a minute is different. And does modern science falsify it? We'll see. I just want to talk a little bit about the history of where this comes from, or where does the young Earth creationist idea come from anyway. Largely it's attributed to this guy, the Bishop Ussher, I think Ussher was his name. Yeah. Who, using a variety of serious academic techniques for that time, genealogies, anthropologies, histories, studies of linguistics, study of artifacts, he developed an idea that the Earth was formed, according to the Bible, on March 22nd, 4004 BC at some time in the evening. So he was quite specific about it. He was not the only person that was doing this. I do want to read you. There was another guy, John Lightfoot, who is not as well published, but came up with a very similar idea. And I just wanted to read you the title of his book, which is A Few and New Observations About the Book of Genesis, the most of them certain, the rest probable, all harmless, strange, and rarely heard before. That was the title of his paper, revealing the age of the Earth. The paper also had a subtitle, which I'm going to read to you now also, because it is equally ridiculous. A commentary upon the Acts of the Apostles, ironic and critical, the difficulties of the text explained, and the times of the story passed into the annals. From the beginning of the book to the end of the 12th chapter, with a brief survey of the contemporary story of the Jews and Romans down to the 3rd year of Claudius. So this is what was going on at the time. And this was very much supported by the churches. And this is largely where modern young Earth creationism gets its information from, were these guys. As the scientific method started to develop, people thought that this couldn't possibly be. So even back, so now we're talking about Alfred Kelvin, who's most famous for formulating the Kelvin temperature scale, which identifies an absolute zero, which all molecular motion ceases. And based on his knowledge and his working knowledge of thermodynamics, he estimated, based on the known mass of the Earth at the time, how long it would have taken the Earth to cool down to its current temperatures based on his work on thermodynamics. And he said, no, the Earth has to be 20 to 40 million years old based on the thermodynamics alone. He had no knowledge of radioactive decay, and a lot of the heat temperature that we see in the Earth's crust today comes from radioactive decay. So although he pushed the age of the Earth back more than 20 million years from the church, he was still way off. In the modern era, fueled by the discovery of radioactivity, Ernest Rutherford is seen here, father of modern radioactivity. He suggested to his friend, this guy B.B. Boltwood, that you should test my ideas of radioactivity on measuring the radioactive content of rocks. And so this guy Boltwood tried the method out on rocks. And from there, the method of absolute age dating of rocks was developed. And by absolute age dating, even in the 17th, 18th, and definitely in the 19th centuries, geologists were able to correlate strata across large swaths of the Earth. So we were able to identify, for example, even in the 18th century, that the mountains that are in the northeast part of the United States, the Northern Appalachians, are the same mountains that are found in the Scottish Highlands and then up along the west coast of Norway. And so geologists were able to correlate strata over wide swaths of the Earth, I want to say, but they weren't able to pin any absolute ages down to them. They could just say that these things were contemporaneous, or this is younger than that. But then with the advent of this radiometric dating, they were actually able to put absolute ages on things. And very briefly, I'll just explain that the way this works is that if you have a radioactive isotope, and down here, this is a table of nucleotides. So we've all seen the periodic table of elements, which has caused trauma and nausea for chemistry students worldwide. If you ever take any graduate level classes in chemistry, seek professional help. But you will come across the periodic table of nucleotides, which shows, so the black ones are the elements, but then the blue and the orange and all these other things are isotopes of the elements that are unstable and undergo radioactive decay. And so you have a fixed amount or an initial amount of the radioactive isotope that's called the parent isotope, and that is the Y naught. Why not? They said. The Y sub zero here, this is the initial mass of that isotope. And as that isotope undergoes radioactive decay, and I won't get into radioactive decay in any detail here, it will form a daughter isotope, which is what the Y here is in this equation. And then based on the time involved in the radioactive decay and the decay constant, which is this K right here, you can determine how old the rock is. And so there are different, based on the ratio of the initial to the daughter isotopes, and I'm talking about the ratio of their masses found in the sample. And so there are different types of radioactive clocks. There are things that we can use to date things that are relatively young. So for example, carbon-14 will decay to nitrogen-14. And by measuring the ratio of these two masses in a sample, we can determine how many half-lives the sample has undergone. And the half-life is the number of years it takes for half of the parent to turn into the daughter. And then there are also geologic clocks that are very old. For example, uranium-238 down here on the bottom, are very long-lived, has a half-life of 4.5 billion years. And so we can use this to date rocks that are very old. And that's exactly what we've done with rocks that we found all over the Earth. And these are some samples. When I was a graduate student at the University of Florida, one of my jobs was to separate these crystals, these are zircons, out of rock samples. So we'd get these just bags of powdered mica, and I'd have to sift through it and pull out the zircons, because the zircons are very stable minerals, and they incorporate uranium into their crystal structure. And so if you pull out the zircons, you grind them up into a powder, you put them in a mass spectrometer, and it will tell you the ratio of the parent isotopes to the daughter isotopes here. And you can plot where your sample falls along this curve, and it'll tell you how old your sample is. So this curve is the derivative of the time here function. There's a lot of math, but and so the oldest zircons that we've all found, and when I say we, I'm talking about geologists around the world, so hundreds of geologists who've been doing this for a long time. All of the oldest zircons that we found all coalesce around this date here, around 4 billion years. Overwhelming evidence for that, in fact. These down here, these are meteorites. And so this is even more relevant information because the meteorites formed in the solar system before any chemical evolution took place on Earth. So in order for these zircons to crystallize, already the Earth has evolved chemically. It's cooled, and in cooling, different minerals fractionate out different elements. So already the zircons have undergone some chemical differentiation, and they coalesce around this date of 4 billion years. The meteorites that have hit the Earth, and there are special types of meteorites that you can use to date these, to do this accurately, which I won't get into. These all coalesce around a date of 4.5 billion years. So the meteorites are a little bit older. And so the solar system, it's believed, formed within this age range down here. And it took about 500,000 years. I'm sorry, it took about 500 million years for the Earth to form these stable zircon crystals. So that's what modern science tells us about the age of the Earth and why it tells us that, in brief. The Vedic version, as we read in the Bhagavatam, operates on these cycles of time, in which, so MA is mega annums, or millions of years. So Satyuga is 1.7 million years, and they reduce. Treta Yuga is 1.2 million years. Dvapara Yuga is 0.864 million years, so a few 100,000 years, and Kali Yuga is half of that. And then a Maha Yuga is the sum of this, which is 4.3 million years, so much shorter than the known age of the Earth. But a kalpa is 1,000 of those. So a kalpa is 4.32. This is giga-annum, or billion years, which kind of agrees with what the sciences say, but this is 1 day of Brahma. And then the night of Brahma is the same length. So a day and a night of Brahma is about 8.64 billion years. And then Brahma lives, as we were just about to read in the Bhagavatam, Brahma lives for 100 years of his day and nights. And if you add up all the math, you get that Lord Brahma will live for 311 trillion years. And based on what we know from Vedic scholars, and I don't have a reference offhand on this, but we are about halfway through the life of Lord Brahma right now. So say Lord Brahma has been alive for about half of that, which is 155 trillion years. Again, way older than what the scientists say about the age of the Earth. So how do we reconcile things? So the first, to answer the question, to come back to the original question, so modern science doesn't disprove Vedic claims about the age of the Earth. And why is that the case? Hold on, let me go back. Why is that the case? The case is actually it's because the Vedic claims about the age of the Earth are not scientific claims. They are by definition not falsifiable, because if we go back to these clocks, there's not a clock long enough to measure something that long. So it is a claim, but it doesn't really fall within the purview of what we know of as science, because there's no way to falsify it. So it's not a falsifiable claim, which means it can't be falsified. So for me, I will say as a devotee, that means I'm free to believe it, and the scientists can't tell me I'm wrong. Take that, scientists. But then how do we know that the scientists aren't right? So to quote, my favorite band, I ain't often right, but I've never been wrong. So we might not be wrong, but how do we know that those guys aren't right? Anyway, so a couple questions to bear in mind when thinking about this is, where exactly in the lifetime of Lord Brahma are we? And we also know that in the days and nights of Brahma, there are partial devastations of the universe in which this earth does get destroyed, or at least it gets covered by water, or burned to a crisp by fire, or withered away by air. So there's descriptions of partial devastations. And where exactly are we? And do those partial devastations line up with anything that we do observe on Earth? We do know, for example, there have been periods of time in the Earth's history where the Earth has been all ocean. And we know that there have been periods of time in the Earth's history where it has rained for millions of years. Or time periods where, for example, it's been much hotter than it is now. And there have been mass extinctions. And so some things that people may point out, and the young Earth creationists also point this out, that, well, the radioactive decays that we see now may have changed over time, which is giving us an artificially old impression of the Earth. And so if that's the case, so, okay, that is a fair claim, I think, from a purpose of debate. If the rates of decay change over time, what we see as the age today might have been different. And so, but for the Earth to be artificially young, so in other words, for the rates of decay to be giving us artificially old ages of the Earth, that means the rate of decay in the past would have to have been much faster. And we know from laboratory experiments that fast radioactive decay fries things to a crisp. That's what happens when a nuclear bomb goes off. So if the rates of radioactive decay were much higher in the past, life would not have been able to survive. It all would have been ionized. We could say from our perspective, or from the Vedic perspective, that perhaps the dates that absolute age dating give us are artificially young because the rates of radioactive decay were much slower in the past, and they've sped up recently. That is also a fair claim, but there's really no evidence to support that claim. So the rates of radioactive decay of uranium, for example, have not changed significantly in the 100 some odd years that we've been able to measure it. So if it hasn't changed in 100 years, what is the logical basis to think that would have changed in 1,000 years, or 1,000,000 years, or 1,000,000,000 years, or 1,000,000,000,000 years? At what point does that become a reasonable hypothesis? But then from the scientific perspective, what sort of evidence would you expect to find for that? And so I think this is an example, again, talking about epistemology, that we have to be careful in the ways in which we use the word science. Because we might want to use the word science for our own purposes, but that's not what the world is understanding science to mean. And for preaching purposes, it's important to be able to speak the language of the people that we're interfacing with. And so again, this is an issue that if we're talking about Vedic sciences, we really need to be able to explain what is scientific about it. And in order to do that, we need to be able to understand what is science. And in this case, I'm using this example of the age of the Earth as a believable unscientific claim. It's unscientific because there's no evidence that we know of that can falsify it. But that's exactly what makes it believable, right? nobody can show me that I'm wrong. But I think that, and as we get into kind of the home stretch of these seminars and we start talking more about consciousness, this starts to become a very important question. So the same is true with studying consciousness. What are the hypotheses that we're making about consciousness? What are our reliable and valid tests? And what is the role of peer review in talking about consciousness as science? And then finally, an important an important aspect of science is that science has to be predictable. So what do our theories of consciousness predict? And on that, I'm going to stop. I'm going to stop and see if anybody would like to say something.
Thank you very much. Very, really interesting. Yeah, any questions or concerns, you can pop them into the chat, raise your hand, or just.
I think we have a guest playing Dungeons and Dragons on here, and it is not frontier.
Dr. Rich, you can go ahead and unmute yourself.
What is you said epistemology? What is epistemology exactly?
Yeah, good question. Epistemology is the study of knowledge. So how do we know what we think we know? What is the nature of evidence? What is the nature of the burden of proof? Things like that. Epistemology is the study of what we know and how to gather knowledge.
I guess here I can make a plug for June 10th. The final lecture in presenting mechanistic and non-mechanistic science by Sada Puttadas. I'm going to be giving the lecture, and the title of the chapter in the lecture is The Epistemology of Transcendental Consciousness. So actually it's going to deal with some of these questions here, the same, what are the hypotheses, what are reliable and valid tests, specific from Sada Putta's point of view as like a mathematician talking about like the way we think of science, modern science, as being very quantifiable and numbers oriented, and how that can or cannot be related to transcendental consciousness.
Cool. Here.
Yeah, that'll be here. Yes. I also wanted to make a comment about the atom. So I learned this from Atma Paradigm, where Akhandadi Prabhu talks about the Sanskrit term paramanu, which is what is translated as atom in the Srimad Bhagavatam, and that the paramanu is actually kind of a little bit different from what we think of as in science as the atom. So and that comes from the slightly different approaches that Vedic scientific philosophy, or some might call it Sankhya, and our Western science, these have slightly different approaches to things, to like reality. So we think of the atom in modern Western science as sort of this like objective, indivisible unit, whereas the paramanu is more of like the smallest unit of perception, or like of subjective experience. So if you think about like pixels in a computer screen, and how these pixels are sort of the smallest unit of subjective experience for when we see like an image on the screen, then that's kind of like what a paramanu is. Like it's sort of like a pixel that the kind of the modes of nature and the Vedic scientific ideas of like kind of reality being very perception focused. Like it's more of that perspective rather than like this objective tiny object.
Well, that's Akhandadi is not here to explain that for himself, so I'm not actually going to take your word for it, because that sounds to me to be explicitly not what the passage I just read is saying.
Okay.
So, yeah, that's interesting.
I have a question.
There's hold on. There's also a whole. So we are Bhagavad Vedantas here in the Hare Krishna movement, but Bhagavad Vedanta also encompasses all of the Sat Darshan of Hinduism, one of which is the theory of atomism. So again, I don't know exactly what Akhandadi is referring to, or the parts of the Bhagavatam that he's referring to in discussing Paramanu like that, but there's a very rich tradition of Vedic and Vedantic scholars talking about atomism very much in the same way that we understand atoms as the fundamental objective concrete building blocks of all other matter substances. So I do want to, again, without knowing exactly what Akandani is referring to there, want to make the point that there is a definition of the atom as we understand it in Vedic scriptures as well.
Okay, well, yeah, I would just bring that up because even when we were talking about those passages here, it's a little bit like, oh, well, what is the hexatom and everything, like, what does that kind of mean? And that at least, well, I guess what I could say that is safe, that is like, it might indicate that we need to, investigate a little bit more about like what atom means in this context.
Yeah,
Okay.
yeah, absolutely.
But yeah, I think it's in part 4 of Atma Paradigm.
Let me ask a question, Pacharananda. I thought you first a comment that you gave a good history of time and how it works and the geological stuff, and I didn't realize you actually looked at your own zircons, which is this kind of standard.
Oh, I didn't look at. I just prepared the zircons. They just
prepared it. Okay. How does Einstein relativity of time fit in with any of this?
Well, I don't know actually that much about Einstein's relativity of time, so I don't want to say too much. But I will say that the Einstein, the difference between Newtonian time and Einstein's time is that for Newton, time was absolute, which means that there was a relationship between time and space, but it's mutable. Whereas in Einstein's theory, our perception of time is dependent on our position relative to that which we are observing. And so that can change. So for example, I was talking with, I don't know if Christian's here, but I was talking with Christian about this on the phone. So this has to do with how fast often somebody is traveling in relationship to the object they're observing. And the faster that we get to traveling at the speed of light, which Einstein described as a finite measurable property, the slower time appears to be moving, which is why if somebody is traveling at the speed of light and we fly off to Alpha Centauri and come back, we will not have aged, but everybody here will have aged according to how long it took the light to get there and back. And so I thought it was interesting. And this also then relates to gravity, because there's energy in light, and we know that from Einstein that energy and mass are related by the speed of light and a constant of integration. And so therefore light is also affected by gravity, although it doesn't have mass, and therefore we can see gravitational lensing around galaxies. And that's one of the ways that we've proved Einstein's theories, or let's say validated Einstein's theories. And that's also one of the ways in which we can tell how far away distant objects in the universe are. And so one of Siddhartha's theories was that based on the description of the size of Satyaloka and just the dimensions of this, let me make sure I say this right, that Satyaloka must have so much gravitational pull that it acts as if it's a black hole, based on its dimension. And as things approach a black hole, time starts to get warped, things start to slow down until you get to the event horizon of the black hole, which is where time freezes. And so the event horizon of the black hole is the area around the black hole at which, on one side of the event horizon, the light can move, and on the other side of the event horizon, the light is captured. And at the event horizon, whatever just went into the black hole appears to have stood still. And this would explain why time is expanded in the lives of the demigods, which I think is a very interesting explanation for that phenomenon.
Yeah, that's where I was headed with this. It is, and we have stories in the Bhagavatam of Arjuna and others going to the heavenly planets. So when they come back, time has moved so quickly for everyone else, but for them, it's just short moments.
Yeah, and Prabhupada also explains that, if people traveling at the speed of the mind can actually travel faster than light. And so we know that from the Vedas that people who are imbued with mystic powers, can astral travel, but not just like astral travel, like I'm going to like, you know, the local yoga club on a Saturday and like doing an astral travel workshop, or I'm doing some
Yeah.
like lucid dreaming with my chamomile tea or whatever. They would like pick up their bodies and move it to another planet at the speed of the mind, or they would just inhabit another body on the other planet. So they would be able to interact with matter, not just as a consciousness experiment, but they would be able to fully interact with matter. And they were able to do this at the speed of the mind.
Yeah, yogi cities.
Yeah.
Yeah.
So what we
Okay,
as
thanks.
devotees, we are not after yogic cities. And I think it's
Um,
important to remember, because these are attractive. Like, how cool would that be? You know, I want to go to, where do I want to go?
The moon.
I don't know. I don't know. I want to go to the Pacific Northwest. I want to go climb a mountain somewhere, wherever we want to go. But really, we're interested in worshiping Krishna. And so, what am I going to do on the moon, right?
Start a
Worship
temple.
Krishna.
Yeah, open a temple on the moon for the next Apollo mission. All right. Any other questions or comments? Yeah.
Thinking about the falsifiability of like theological claims, it seems to me like the young earth, like Christian theory would be unfalsifiable for the same reason. Like as soon as you throw an omnipotent being in, like all bets are off, right? You could say of course we have evidence that the earth is older than 6,000 years, but
Yeah.
a god could certainly create a 6,000-year-old world in which we would perceive it to be billions of years old for reasons we can't comprehend.
Right. Yeah. And yes, and that is the common argument that you will hear amongst the young earth creationist forms of Christianity, is that, well, all that other evidence that you're looking at is
maybe he's just doing that to test our
Satan
faith.
just put that there. And okay, I mean, that is a belief, right? And this is America, and everybody's free to believe whatever they want. I respect that. But this is why it's a leap of faith and a leap of doubt. They're taking a gigantic leap of faith, and their reasons for doing that are not based on sort of the rules of the road of epistemology. And so there's evidence, but then, so that's one aspect of the epistemology, is the nature of evidence. And we talked about the nature of evidence, but then another aspect of epistemology is, what is the burden of proof? Like, what type of evidence would convince you that this is right? And I see this with flat earthers all the time. It's like, I don't, and they want me to look at their models again. And like, I've looked at all of this, But what would it take for you to be convinced? Like for example, I'm not to belabor the point with flat earthers, but I have a friend who is a flat earther who's like adamant and aggressive about it. And he's also very much like a Prabhupada setist. Prabhupada said, Prabhupada said. And I said, okay, if I could show you 5 pages of quotes from Srila Prabhupada explaining that the earth that we live on is a round globe, would you then believe it? And he said no. He said, I would need to hear the tapes, because he's taking his conspiracy-addled mind just the next step further. They could have documented the transcripts. I want to hear the tapes, but then you play them the tapes, they doctored the tapes. And so this is not how intelligent discourse takes place. So, at some point, the people need to be kicked out of the club. So there are rules, and I think this is one of the and certainly in India, we see this from Lord Chaitanya, at least from Lord Chaitanya's time on, and I'm sure others on the line can speak to it more clearly from ancient Vedic times. But there's a rich history of philosophical discourse and debate, and there are rules to this. There are rules to logic. Like in our geometry class for 9th graders, we teach them logic, if-then statements, and what is the contrapositive, and what is the inverse, and what is the converse, and what is the antecedent, what is the precedent, and this is all basic logic. And people who can't adhere to like we were having these discussions with these 2 guys on Facebook over the last week. It's like so there's a burden of proof, and and this also gets into scriptural interpretation and hermeneutics. Like, so the house is on the Ganges. You can't take the face value of that literally. The house is not on the Ganges. There's some figurative interpretation for what that means, and then there are rules of how to go about doing that. And so the young earth creationists can come And their burden of proof is that Jesus Christ has to come down here on a white horse and himself tell me that the earth is 4.5 billion years old. And until that happens, it's all the work of the devil. That is not a scientific position to take either. Because that is not I mean, is he going to call me on the phone when Jesus does this so I can see it?
A phone call would be,
I mean,
Yeah, and it's probably theologically debatable too. Like even
Yeah.
with their scriptures, and it's not necessarily logical.
well, my karate teacher is not a young earth creationist, but he is very much a fundamentalist Christian. And so we discuss these things sometimes, and he does send me, links of people, and there are very serious biblical scholars who know biblical Hebrew and go back through Genesis and all of it, and who understand that the position that the earth is 6,000 years old is untenable, but still want to honor their biblical faith, and so they look at other ways of interpreting what the Bible says in relation to what we know modern science to be. So we're not alone in this sort of leaps of faith and doubt. It's just something that faces us all in society. How do we know? How do I choose to believe what I believe? Yeah. Anyway,
I like how
thank you. That's a really great point.
you started that off with saying my friend, because it gives space for people to believe what they want, and then
Well, he blocked me, my friend.
Okay, well, maybe not that close of a friend.
Okay, I'm his friend.
But that's the important thing. But what's important is not to fight with people, but for us to understand what is intelligent discourse and what is reason and logic, and then go from there. And if people want to believe, fine. But what my question was about, what you said, that it's not falsifiable, the Vedic claims. So it's not falsifiable, but does that mean that it's not provable also? Like we couldn't get more information, empirical?
Well, in science,
knowledge
nothing
and
is
prove it?
provable. You can't really prove anything in science because there's too much data in the universe. We couldn't possibly collect it all, and we can never really rule out the possibility that there's some other point of evidence that we just haven't discovered it.
But could we get closer to a correlation so that it's like, oh, this is what the Vedas say and this is what science says, and then, oh, look, they match up.
Yeah, well, I think it's difficult to do that quantitatively because the Vedas are not designed to have that sort of quantitative rigor. That's not what the Srimad Bhagavatam is. The Bhagavatam is a Purana, which means it's a history. It's like a mythic or an epic history. I don't want to use the term epic because the Mahabharata and the Ramayana are epics, which are different categories of scriptures than Puranas. But Puranas are not even like the elite of Vedic scriptures. Like the elite class of Vedic scholars or whatever were more studying the Vedas themselves and the Upanishads. And those were like the academics of the time, the people who were deeply immersed in that. And Lord Chaitanya was that for a time in his life, and before he gave it up. So the Puranas are not meant to have that type of quantitative rigor. And so for example, when we see that, this says 4.32 billion years as opposed to 4.54 billion years, that's
It's negligible.
yeah, it's negligible, but it's also like it's not potentially describing the same thing. So I think it's also dangerous to try to correlate things so finely. I think the more important thing is, and I think this is just like a general orientation towards life, the more important thing is, what do we agree on? Like, where can we find common ground? We're so caught up in finding differences between us that, that our society has just become so fractured, and like everybody's pooling into their own little groups here and there and the other thing because of one thing that I don't like about that other person over there, right? So what is it that we can agree on? Where are the common grounds? How can we use the scientific methodology to further our own devotional practices? But I will also say along these lines that one of the reasons that we're doing this is because Prabhupada did want to preach to scientists. Prabhupada recognized that even if like the lay people, and I know Stita, I don't know if it's here, but I know Stita liked to make this point that actually our society is moving away from science, and our society is becoming progressively more and more scientifically illiterate. But that doesn't change the fact that our civilization is still governed by science. All of our technology comes out of the scientific method and is maintained with those principles. You know, if something breaks, how do we go about fixing it? This is all science.
He
or-
brought
and
this up
technology.
yesterday.
Yeah, and so,
26% of only 26% of Americans have any faith in science.
but every American has faith in their cell phone. Right?
Yeah.
So there you go. And so Prabhupada was very much interested in preaching to scientists. And Prabhupada wrote this famous letter that, you know, scientists tend to be puffed up, academics in general tend to be puffed up, but we also need to be able to listen to them, and we need to be able to engage with them using their language. And the point is not that the Bhagavatam is right and the science is wrong, or this is what the science can learn from the Bhagavatam, or this, that, and the other thing. The point is that everybody should take Krishna Prasadam and chant Hare Krishna.
That is our philosophy.
Yeah, the point is that everybody should be chanting Hare Krishna. And when scientists read our scriptures and the things that inspire us to chant Hare Krishna and go, wait a minute, that's not what I learned in graduate school. We need to be able to engage with them in an intelligent way. And that doesn't mean that we need to be able to convince them that they're wrong and we are right. But it does mean that we need to know how to communicate with them in a way that has intellectual integrity. And that's what's missing from the young earth creationists or the flat earth. Let's not pick on the Christians, but let's pick on the flat earth. They're non-denominational. They're nuts. Yeah, that's what's missing from there, is they don't have any intellectual integrity in their debate. Because then they'd have to admit that they're wrong.
I have another question around time. My understanding is that there's nowhere in the Bhagavatam where time travel into the past is described, but to me, I'm thinking, how is that possible? It's so prevalent in our culture to talk about time travel. And I'm thinking, if we can conceive of it, isn't it that it's possible? Or I don't know. What are your thoughts on that?
Say it again. I was distracted by a comment on the chat here. I'm sorry. I heard time travel
into the past. It's not in the Bhagavatam.
Yeah.
Does that mean that it's not possible and that it's? How is it that we can conceive?
Oh, I don't know. I mean, I guess conceivably we could travel into the future through a wormhole. I don't know how you would travel backwards into the past. I don't really know. That's it. But then that's a technology issue more than anything. I mean, I look at that as a technological problem, not a philosophical problem. Like if I go back into the past and murder my father,
it's not logical.
I'm not this body, and that guy is not my father. So who knows what that will do, but that's not like a philosophical problem for me. Or traveling into the future, I don't know. That's a technological problem. How much energy would that require?
21 gigawatts.
1 gigawatts. Yeah, no, it would require a lot more than that, actually.
We have a hand up.
Yeah.
Dr. Rich, go ahead.
Thank you for the Back to the Future.
I just wanted to know, you know, I think you talked about the speed of the mind. Does anybody know if the speed of the mind is as fast as the speed of light or faster?
It's faster than the speed of light.
Thank you.
You're welcome.
Or is that science, or is it just what is said? I mean,
No, that's not science. Science doesn't have the speed of the mind. Science doesn't even recognize the mind as anything not related to like biology or organic. And that's really, and so this is where this whole lecture series is going. We've been kind of starting at the beginning, where the universe came from, how science works, and now talking about time, perception of time. I do want to put a plug in here. Next week I am out of town, so no seminar next week. I know, I gotta go.
Okay.
I'm going to visit my favorite fundamentalist Christians.
Okay. Road trip.
Road trip. Just not the road. And so the next week we're going to talk about evolution, which is
In 2 weeks.
in 2 weeks. Sorry,
Okay.
yeah, the next week.
Evolution. Is this about the mouse deer?
The mouse deer and the
Okay.
whales, yes. And
Mouse
so we're going
deer.
to talk about evolution. So gradually we're getting more into less hard science and more conjecture.